Okay, so beginning of the next chapter, what we're going to learn about are things called operations on functions. And the hardest one is composition of functions because it is totally new. All right, and so I'm going to do a little bit of prep work on what you have to be able to do to find the composition of two functions. All right, it's a way of combining two functions. And the key is understanding function notation. If you don't understand function notation, then this is basically impossible. So let's say you have a function x squared minus 2x. So f of negative 2 is what you get when you plug in negative 2 for x. So let me actually cheat a little bit. I've got little templates here. So I'll bring it up. Okay, and so remember what that means. X squared minus 2x. So something squared minus 2 times that same something. Alright, let's see if I can get the pen was not working. Let's see if I can get it working. 2 negative 2 negative. Okay? Negative 2 squared minus 2 times negative 2, so you get 4 minus negative 4, so it's plus 4, so it's 8. Alright, so we have an interpretation of what that means is that for this function, if you plug in negative 2 for x, y equals 8. Alright, but you don't have to have that kind of interpretation to be using function notation. It could be something more abstract, kind of weird. You can have other expressions, don't have to be numbers. You have other expressions plugged in for where the x was. Okay, so like right here, there's one of these. You've seen these before too. Okay, and so all that means is that a plus 5 is going to go in. So a plus 5 is going to go in here. And here. Okay, oops, a plus 5, not a plus b. Okay. And then you just simplify it. Okay. So I'm not going to take too much time doing that. But when you square this, it's really you're just foiling something times itself. That's one way to think of it. So when you do that, you get a squared. When you FOIL, you might want to pause it and do this yourself. So you might want to pause it now and go a plus 5 times a plus 5 in parentheses. Alright, so you can pause that now if you want. Alright, and so what you end up getting is okay, minus 2a minus 10. Okay, negative 2 distributes to both parts. And you just combine like terms and you get a squared plus 8a plus 15, and that's that. So your answer is not a number, but it's an expression involving a. Alright? So you, last but not least, you can do the same thing but without changing variables. Okay, so the variable initially is x. Well, we can keep it as x. And actually what you can kind of think of this as, if you want, is that this expression here, you can think of this as another function if you wanted to. You could think of this as g of x. We'll say g parentheses x. It's the label saying that g of x, you know, if you wanted to think of it as a function like we've thought of before, where it's you plug in x and figure out y. This is a linear function. 5 minus 2x is written a little weird, but it's got a slope of negative 2, a y-intercept of 5. It's a linear function. Alright, so what you're doing is you're putting the equation or the expression for a linear function into another function, which is the one we've been working with on this page. Okay, so you get the 5 minus 2x in there, okay, and then in there again. Alright, so you've taken one function and plugged it into another function, okay, and then you just simplify, very similar to what we did up here with the a plus 5, okay, so you get, now just bear with me, you might want to pause it and FOIL the 5 minus 2x out like you might have done before, maybe not. And so what this turns into is, let me leave more room. Let me do this. 25 minus, I'm having a brain fart, minus 20x plus 4x squared minus 10 plus 4x. Okay? And then you combine all the like terms and you get an expression. Notice, as I keep on trucking here, that what we have is another expression that looks an awful lot like a function. I lost track. 15. So this is f with, let me actually change this to, whoa, that was a silly accident on my part. F, I'm using the black for f, and then with g of x, the expression for g of x, remember g of x is equal to 5 minus 2x with g of x plugged in. Okay, so this, notice this is something, if you plug in at x, you could crunch these numbers and get an answer. You could plug in x and get a y. That's how functions work. So this new thing we just made by combining f and g is another function. Alright? That is how composition of functions work. A composition of functions is a way of taking two functions, smush them together, and making another one. So you take this linear function, 5 minus 2x, combine it with this quadratic function up here, and you get, well, another quadratic. Alright? That's composition of functions. What's going on here? Oh, here we go. Boom. This is what I want. Stuff got out of order. I freaked out for a second. Thought it was gone. Alright. So composition of functions is a way of taking two functions and combining them. So pause and read this. This is a little bit of an abstract thing. It's a new, definition here. Okay, and composition of functions is a way of taking two functions, combining them, and getting a new function. And it's all the work we just did right down here. It's all this. So it's all about plugging in and simplifying. Okay? Alright, so the other stuff in this section is addition and subtraction, multiplication and division of functions, but that is much less difficult than the composition of functions. So this is what I want to concentrate on. Composition of functions. And so instead of a plus, a minus, a multiplication symbol or division symbol, it's a little O. So if we're taking two functions, f and g, g and f, those are our labels for the function. That's what the function notation is useful for. It's labeling different functions. We have more than one of the same problem. Then to combine them, the symbol you use is a little circle. So this means f composed with g. That's how we could say that. Or the composition of functions of f and g. Okay? Or vice versa. F composed with g of x. This is a composition of g and f. Right? Which actually aren't necessarily the same thing, as we're going to find out. So then what we do, it's all about plugging in and simplify. Notice it's f of x is inside g of x here, and vice versa here. So the second one listed goes inside the first one. So the plug-in is a replacing of the regular variable x with the expression g of x, or vice versa. So let's actually do some examples. However, let's do it with numbers. Numbers are a little bit easier. So we have two functions, a linear and a quadratic. So what this means here, what the definition of this is that we're going to plug in. So how we write it is we go f, and then inside of f it's whatever g of negative 1 is. Okay, so g of negative 1 is your x value, and then we're going to find g of negative 1 by plugging it in here. So f and g of negative 1, leave some space, here's g, 9 times something squared minus 4. That's what g always does. In this case, the number is negative 1. Okay? Which equals 5. F with a 5 in there. So if you crunch these numbers, you get 9 minus 4, so 5. Okay, so the y value in g is 5. And then what you do is you take that y value and you've plugged it in for f, or into f. So the y value for g actually becomes the x value for f. And so you go f of 5 is 3 times 5 plus 5, so it's 20. Okay? Vice versa, and with a different number. I guess I probably could use the same number, but I'm already started, so forget it. Alright, so it's, oops, I started messing up. It's g is what I write first. Okay? I'll speed it in. G with f of negative 2 plugged in. So x value is negative 2, and we're going to plug it into f. So g with, I forgot what f was, 3x plus 5. So 3 times negative 2 plus 5, which is negative 1. Ooh, we already did that actually. Okay. We know g of negative 1 is 5, so I'm going to just write the answer. That's what we did in the previous. So 5. Okay? So you plug in an x and figure out a y. It's just it takes multiple steps because there's multiple functions involved. Okay? So these are two functions. Okay? Where you plug in an x and get a y. So whatever this function is, you plug in x. When x is negative 1, y equals 20. Whatever this other function is, when you plug in negative 2, you get 5. So let's actually get equations for those functions by not actually plugging in numbers. So I skipped a little bit here. I'm going to try to color coordinate. So f is blue, g is red. Okay, so f of g of x, f composed with g of x, means you're going to take the formula for g and plug in for f. So the f is, what is f? 3x plus 5. So I'm actually going to cheat a little bit and do this. So that equals 9x squared plus 4 gets plugged in to f of x. So, I'm going to copy and paste. And it didn't really do exactly what I wanted to, but that's okay. I guess. I don't know, that's frustrating actually. Let me pause and fix that. Okay, so that's what you get. G of x is plugged into f. So f is 3 times something plus 5. Okay? And then the something isn't x, it's this whole expression. So then what we do is we spin back and we just do the arithmetic. We simplify. So it's, or not arithmetic, but algebra. It is 27x squared minus 12 plus 5, so minus 7. And that's your final answer. Alright? So you might want to pause. If you plug in, by the way, if you plug in negative 1 into this, you actually get 20. Alright? So let's do the same thing but in reverse with f composed with g of x. Or, excuse me, that's what we just did. We want to do g composed with f of x. So let me pause it and get it all set up. So we take the formula for g of x, or for f of x, excuse me, 3x plus 5, and replaces x in the other thing. So it was 9x squared minus 4, but no, now it's 9 times the blue function f squared minus 4, and then we just do the arithmetic, right, or the algebra. Okay? So here what we do, we FOIL it, and so we get 9 times, this works out to be, okay, so you have to follow on home, 9x squared plus 30x plus 25 minus 4, 4, okay? And then we do distribute and combine like terms. You get, I'm going to pause it because we're running low on time. I'm going to pause it and just give you, I'll give you both steps here. So distribute to 9, combine like terms, 225 minus 4, and there you go, you get another function. Actually, if you plugged in negative 2 into this guy, you would get the 5 that we got there in the second example. So hopefully that is helpful. There you go.